Now, just 3.5 million years ago, a massive energy flare ripped through our galaxy. Its impact was felt 200,000 light years away. This new discovery that the Milky Way's centre was more dynamic than previously thought can lead to a complete reinterpretation of its evolution. The team behind the discovery, led by Professor Joss Bland-Hawthorne from Australia, used the data gathered by the Hubble Space Telescope to calculate when the massive explosion of high-energy radiation took place. Professor Hawthorne told me why the discovery is so significant.
When gas clouds and stars fall into the centre of the galaxy, they go into a death spiral around the central black hole. We have an enormous black hole at the centre of our galaxy, 4 million times the mass of our sun. The black hole itself is invisible, but this spiral of gas going around the center of the black hole gets very, very hot indeed, then blows off jets, winds, and bubbles into the surrounding galaxy. So what we've seen is evidence of the explosion 3.5 million years ago. A giant beam of radiation, like a lighthouse beacon, flashed from the galactic center and went right across the galaxy and lit up gas a long way out from the center of our galaxy.
We just saw some pictures there to give us a sense of what this is. But given this is at the centre of the galaxy and given that Earth is far away from it, are we in any danger of this flare and what it's producing?
It's a very good question, because our black hole, in fact, the disk around the black hole does flop around a lot. It's not like the very, very massive black holes in quasars at high redshift we see in the distant universe. The ones that we see in the local universe flop around. In actual fact, the jet beam of radiation could indeed come in our direction. And that's an interesting question, because it could have happened in the past, it could happen in the future.
So now that you've discovered this, what does it tell you? Why is it important?
It's important because we now know that essentially all galaxies have these massive black holes in their centers. But if you look out into the local universe, very few black holes have these shining disks right now, maybe a few percent at most. But I think what it means is that, in fact, they all have these events at the center. And the reason we only see a few percent which are bright today is because they're flickering. They turn on, turn off, rather like fireflies. So you can imagine with your flashlight, if the battery was packing up, your torch starts to flicker. So I think it's a bit like that these black holes flicker over thousands of years. And I think the amazing thing for us was to find our own Milky Way is just one of those sources. We have a flickering black hole at the center of our galaxy.